Okay, we're here. We're live. Oh, I've been live? Am I live? Let's see. Yep, we're live. Okay. Making sure my my indications were not making it obvious that we were actually live here. Okay. How are you doing? It's been a crazy week, busy week. It's been a lot. I hope you're doing well though. I'm doing well. I put out the video the other day just talking about things are going to probably be a little less consistent. There's going to be more irregularity happening overall. So far, I feel like I'm doing pretty good with the stream, even though like we should have a stream next week, but then we're going to have a 2 week drop off, maybe just 1 week. We'll see how it goes because I'm going to be traveling. So I've got 2 weeks of travel coming up. So we're got the hands-on class in April. That'll be coming up in 2 weeks, and then I'm gonna be in DFW for basically a week. It's technically two classes, but anyway. By the way, one of those in DFW I do plan to stream. It's going to be at their CSG's Arlington location. So we're doing a class up there. I've worked with Compressor Solutions for a very long time. Absolutely love the folks over there. And here's something. This isn't a defense of them, but it is something I do want to point out because I have some folks reach out every now and then and just be like, you work with compressors, like we had issues with their compressors and this and that and this and that. And I do just want to try to bear in mind that one, nobody's perfect, but two, sometimes there's just really unique circumstances happening where it's not so much the compressor's fault, it's the conditions around the compressor, but that's not trying to say it's your fault either. An example of this. So I had a scenario where somebody was using the CSG screw compressor rebuild. This was on a YCAS, and they quite literally were on their third compressor, and CSG was like telling them, like, hey, we can't keep warranting this. We have to stop somewhere. So as part of that, I agreed to go out and look at the system and just provide any feedback. Well, getting there, the system was just extremely acidic. The various compressor burnouts that had happened had caused major acidity in the circuit, so that was getting into the oil. Oil changes weren't being done exactly the way that I would have recommended it, and I found that these were TXVs still, so this was pre-EXV setup. The TXVs, or the TXV, sorry, because one big single valve had failed internally. It was sticking. So once we did get the system cleaned up, which took some time, once we did get it to the point where it was going to run, then I found that the valve itself was beginning to fail. And that's what ultimately caused the first failure. The TXV began to stick, and it got hung up overfeeding. That overfeed caused the first compressor to have a flood condition, caused a burnout. Went through two more warranty compressors, and genuinely, like, again, I'm not knocking the people on site. I'm just saying that sometimes we don't realize the conditions we're dealing with, and mistakes happen, and we end up blaming the manufacturers in some cases for this case. And again, this isn't just specific to CSG. Like, these reman shops, like, I've worked with quite a few of them at this point beyond just CSG. They're just the ones that I've got a close relationship with, and many of them actually do a pretty freaking good job. They really do. It's, I don't know, I'm getting off on a tangent here. I'm just going to shift gears. I don't know how to transition out of that. I wasn't trying to get you away off. How you doing, everybody? I see you there, Jason. And I don't want to. Good morning, sir. I don't want to be rude because, to be honest, I'm going to just say Dean, but I don't actually know how to pronounce your name. So good morning to you, sir. I do see a question. Chiller oil pump continue running. Chiller of condition. I don't operate manually. What is the reason? So the pump stays on, but you're not manually turning it on. Okay. Let's see. I do have one question that I want to get to first, and then let's circle back to that one because I don't want to lose this first one. We'll circle back to this one, and we'll start discussing that. Good to see you there, Jason, from the job site, and on our way to an ACR startup. Let us know how that goes. If you got any pictures or anything like that you want to share, by all means, send them over. Okay, we'll dive into the first question instead of listening to me rant about things. Oh, granted, you just listen to me rant about the question instead of just whatever random topic, which is a scary place to be. If we're just in random zone for my brain, I'm telling you, it's a very scary place to be. Ask Jason, he can tell you. Anyway, what if you're recovering gas on a air-cooled chiller, but the ambient temp is 20 degrees Fahrenheit? Would you still use a subcooler? And you would also have to worry about freezing the barrel. I'm going to start off with the last part of that in terms of freezing the barrel. Are we worried about freezing the barrel at all times? Absolutely. Now, there's more advanced practices as you gain experience, yada, yada, yada. I'm not going to get into those things because I don't want, like, those are things that you can and will learn as you progress. So I've become very cautious of recommending or talking too much about some of the shortcuts because unless you do those shortcuts just right, you're going to have problems. So we should always be worried about freezing our tubes of some kind. I will say that on a DX shell and tube, which being an air-cooled chiller, I don't know what kind of compressor you have, but like if you're dealing with a you have less risk with certain types of evaporators. A brace plate or a DX shell and tube, you have less risk of tube freezing issues just because of where the water is in relation to the refrigerant. Again, just less risk, but that doesn't mean no risk. So let's bear that in mind. Where we're really, the evaporators we have to be like highly critical of is when we start discussing flooded or falling film evaporators, because the water is physically in the tubes. It has less space to expand once it begins to freeze. So just we have to keep this stuff in mind. Have to. So we should always be worried about any of our heat exchangers freezing in the process. And that does actually, this may be a good point to bring up for some of these that have the heat recovery or the the water side economizer setups. Not water side economizer, what am I saying? Jason just had one that failed and flooded the circuit. So sometimes there's more than just the evaporator on some of these really advanced machines that will have water in the heat exchanger. The point is, we should always be worried that those heat exchangers need to be protected during a recovery. Always, because the dangerous part is when we have liquid refrigerant making contact with a tube or anywhere that water is also going to be on the other side of that. There's risk of freezing. Freezing has risk of damage. Even if you don't rupture something. So that's the other side of this. Damage goes beyond just having something break. It could be that you end up misshaping the internals of that heat exchanger because the ice swelled and that bend things out of place in a way that has a dramatic impact on how well it functions once you turn it back on. So these are things we have to be thinking about, and we're dealing with very thin metals. Keep that in mind. Our heat exchangers are very, very thin metals. So it doesn't take much to misshapen or manipulate them in any way. They're thin so that we have proper heat exchange values. So it's not like a ACR copper pipe on the outside of the that we do use for line sets. We're not those are extremely thick, and that's not something we would use inside of the heat exchanger because of how thick the walls are. It restricts how much heat exchange we can have, or how efficiently we can exchange that heat. So anyway, point is, now if you're at 20 degrees Fahrenheit already, hopefully your heat trace, your evaporator heaters, all of that is also functioning, beyond just water flow and such. We really need to make sure that everything, all your freeze protection devices are fully functional in that environment, particularly if you're not running a glycol solution in your loop. Now, moving on to the subcooler aspect of this. Now, keep in mind, okay, so before I just assume, I'm trying to get better at this. When we say subcooler, what we're discussing is, let's say we just have a regular air-cooled chiller, okay, so air-cooled chiller, and we're going to do a standard recovery. So what I mean by that is we're just going to have our recovery machine, and we're going to go into our recovery cylinder. And so we're going to come in, we're going to push out into the cylinder, yada, yada, yada. All right, so this is our cylinder, RC. With a subcooler, we're discussing having a heat exchanger of some kind right here between the outlet of the recovery machine and your recovery cylinder. The reason for that is all of these gases that are getting compressed through the recovery machine are building heat of compression in the process. Not to mention, just there's friction flow from just going through the hoses themselves. And if we are in a warm or especially sunny environment, well, this metal cylinder just collects a lot of radiant heat from the solar load, right? So we're talking air cooled, so we're outside somewhere, and if this is not in the shade, especially, maybe getting it in the shade may not be an option in your circumstances. That's collecting a lot of solar load. So that tank is getting hot by itself beyond just the refrigerant heat of compression. As that recovery machine runs, we build even more heat of compression. All of that results in this tank getting a really hot physically, and which builds pressure. Again, same PT relationship we're dealing with here. As this tank gets hot, so does our pressure increase. And the reason we want to keep that pressure down, more than just having the machine max out, because let's say it's a G5 or something, you hit 400 psi, you're done. No more pump. So then you got to change tanks, you got to put water on the tank, something like that. Well, that could get really, really messy really fast. So while you could run water over your recovery tank, recovery cylinder, again, it's just controlling that water, not making a complete mess of your job site. That's where I'm not as big of a fan. So, what we want to do with a subcooler is give us a more controlled way to remove that heat, because the lower we can keep our compression ratio on, or our lift, our differential, or DP, however you want to say it, it's all the same. The lower we can keep that across our recovery machine, the faster our flow is. So if we want a fast recovery, have a low compression ratio. A subcooler here gives us the ability to process out all of that extra heat of compression. Now, it doesn't remove anything to do with the solar load. It doesn't fix that problem. So if you're still in the sun, you're still in the sun, but we're not going to be building heat because of the heat of compression. Now, in your scenario for the question, you're in a 20-degree ambient outside. It's actually to your benefit. I wouldn't need a subcooler. So when I've had cold temp recoveries like this, I have not had to use a subcooler in that scenario. Now, we have to be careful. Things can get kind of tricky because of the low ambience. That refrigerant may not want to pull out of that machine very well. It's also could be common that the refrigerant tries to pull up into the condenser, because the condenser coils are getting so cold, they're likely colder than the evaporator. And if we have a machine that doesn't have refrigerant migration protection of any kind, and we're not pumping down fully, or even if we are, either way, that refrigerant is attracted to cold. That means if the condenser coils are your coldest point. That's where the refrigerant's going to try to go and collect and stay there. So you get into some weird scenarios here with your situation. That being said, it's cold enough outside that your recovery cylinder actually can serve as its own heat sink. So even with whatever heat of compression the recovery machine is putting into this cylinder, the cylinder is naturally just, it has the ability to release that heat on its own without having an additional subcooler in line. Now, if you went with the Navic pump, you could get this subcooler built in. That's my preferred machine on this setup, is the Navic NRDC 4M. You can get those through TrueTech if you don't find them locally. So it's the NRDC 4M. If you didn't know, I do have a code, HVAC time. Get 6% off at TrueTech Tools. There we go. Okay, I got that in there. So realistically, those Navics actually have a really good microchannel subcooler built into them. So it's one of my favorite features, and you have the ability to turn it off and on. So by either going into recovery mode or push-pull mode, you're literally deciding whether to use the subcooler or bypass it. So really, really cool feature. That's one of my key features that I absolutely love about that machine. Anyway, so in this particular case, I would just bypass my subcooler because my ambient is already so low. I'm not worried about building heat in the tank, and if I'm not worried about the tank building heat, that means my pressure is not going to build in the tank. So, like, again, this whole PT relationship all correlates and comes back together. So should we be worried about freezing barrels? Absolutely, all the time. Not even a question. And then would I use a subcooler in those low ambients? No. I would just completely bypass it. It's not necessary. We can move on from that. It's a really good question, though. It's a really interesting question. Yes, on the NRDC 4M, when you put it into push-pull mode, you have bypass. So there's internal valving in there that bypasses the subcooler coil. So you're going straight from pump outlet to the machine outlet port with no coil in between. And when you're in recovery mode, then it cycles the valves around, and you're now pushing through the subcooler coil in order to get to the machine's outlet port. And that's where the AB mode is, whether or not you're running the machine. So there's it's a 4-cylinder. It's two 2-cylinder compressors in there, or pumps. Is a more accurate way to say it. And in A mode, you're running the two pumps in parallel to each other. So they both pull off the same suction and then push out into the same discharge. When you're in B mode, which is vapor recovery mode, I personally don't use it. I haven't found a real benefit to it, but in theory, Navic's position is they're rerouting via internal valves the two pumps into series with each other. And so pump 1 will pump into the suction of pump 2 and then out to your discharge port. So in that case, when they're in series, the idea is it's sharing the lift that the pump has to do, which is going to improve total volume during those low, like when you get to those low pressure vapor pools. So that's the theory. That is the theory. Again, I've not seen that through my own field testing where that made a difference. If anything, with what I've done, I've seen it go slower trying to use B mode versus if I just left it in A. That's been what I personally experienced. But that's also so the argument me and Navic came to was, all right, well, I'm also pulling off of large tonnage, high volume circuits with this machine. When they've done the testing on it, they're doing it through like basically a split or like a 5-ton RTU, right? So you've got smaller pipes, smaller diameter, smaller total flow. And in those scenarios, the machine performed better in B mode when it got down to like 20 to 50 psi or less, somewhere in there. I think is when they want you to switch from A to B. And obviously this would be a high pressure, 410A refrigerant or something. So when we get down to those lower pressures, then switch over to B is their argument. So that's where we came to a middle ground of, okay, well, I'm not pulling recoveries on those. So maybe in my application, that's why I didn't see the benefit, and they see it in other ways. That's how we. Because I challenged them on it. Like when they first sent it to me and they told me that, I was like, it seems kind of weird. I don't know about that. So I did a bunch of testing and did several recoveries where I timed it and did not get those results. And so we had a big long chat about it. I got on the phone with Andrew Greaves and had a really deep discussion around it, and just really like, is this really truly a feature? Like, come on. And that was our conclusion. Anyway, another rant there for you. Hope everybody's having a great day. I see everybody jumping in the chat here. Good to see you there, Tom. Hey Tom, I'll follow up with you later today. I did get that SOP taken care of, so it's just kind of in a final review, if you will, and then we'll get stuff situated. Let's get to that oil pump question. Give me 1 second. Chiller oil pump continue running. Chiller, I think, off condition. I don't operate manually. What is the reason? So if the pump is not in auto on, I'm sorry, if the pump is not manual on in the control panel, but it is still running and activated, to me, my first thought goes to the pump control relay. So with all of these control panels, so my mind goes to, let's just say a YK or a CVH, EF, pick one. They all have a dedicated relay in the panel. Now the YK is it's on the IO board. It's an integrated relay on the board, and it's K1 relay if memory serves. It's for the YK in the OptiView panel. That's going to activate your oil pump. And then on the CVH, it's one of the little expansion modules. I forget which one it is, but one of them has a set of has a little. I think that one actually uses electromechanical relays, because they've got two different versions of them. They've got some that use triacs and some that are electromechanical. I think the oil pump specifically goes through an electromechanical module, so because it is a heavier load, and triacs don't do so well with that. And yeah, that module is what activates the pump. And so there's just two examples of every machine that has an oil pump like that has some sort of output relay. My thoughts are that output relay is probably failed. So, by failed, it probably failed closed, so that even after the machine shuts down and turns off, the pump is still trying to circulate, because even though the relay may have lost its call and it may be told to turn off, the contacts are just physically stuck internally. So that would be my assessment, because that's the thing. There's only there's two things that turn on that oil pump. One, the machine needs to run, so we need lubrication for operation. Or two, we put it in manual for whatever service, right? A lot of machines, you have the ability to put that oil pump on in a manual override on. Yeah. So if neither are true, which you stated that, right? The machine is off, and you don't have it overridden. So you've gone in and verified the pump is in a auto state or an off state at minimum. And that may be something you could try, because that may indicate if it's maybe some kind of weird software thing. If the pump is in auto mode, you switch it to manual off, which you should be able to do with the machine off. It wouldn't let you do that with it running, but with the machine off, you should be able to put it into an off mode. At least on some panels you can. Anyway, just see if it does anything, right? Or you could try cycling it to manual on, then back to auto. Whatever settings you have available will just depend on your panel. We didn't specify which machine you're looking at here. Either way, you probably got a failed relay, which happens. It's not an uncommon thing. It doesn't mean there's anything else going wrong. Those relays just go bad. They fail with time. It's a wear and tear thing. So obviously check the system, check the motor, go through your service checks, make sure there's nothing crazy going on. But outside of that, it's probably just a bad relay. Now, bad relay, let's sticking with my YK or CVH examples, it does mean a module change out. So for a YK, that means that entire IO module has to now be replaced, which sucks, because that relay is not changeable. Yeah, no, it's soldered on. And then on the train, like whatever output module that is feeding that pump, it also has to be replaced. Yeah, so here's a point. Unless the call remains on any, how do an issue with the board? So, I mean, that's a fair point. Okay, so what I'm taking with that is scenario where, so for train is doing it via a communication data bus, right? So train's module is doing it over data. Excuse me, data. But like say a YK as an example, there is a hard output on the ribbon cable from the YK main board out to the IO board. So is there a scenario where the little triac on the main board failed and is sending an output to the IO board and it's causing it to constantly stay on? Yes, I could see that might be possible. So what I would do to verify that would be unplug the ribbon. Because if memory serves, I think, man, I got to pull the schematics and verify. I think the IO board has an independent power feed to it from the main board. Pretty confident. And so if you pulled the ribbon, and let's say the main board was sending an output to the IO board on that ribbon cable that it wasn't supposed to be, you pulled that ribbon and we still maintained the relay, then I would still stick with the relay then. But if the relay does drop out, if the relay does drop out by unplugging that ribbon, then that's another step you would go to. Now, I've never had to do that necessarily, but if you're worried that, okay, is it the main board calling for it, or is it actually the relay on this module? So in the train's case, you could do the same thing with the comm. So if you were worried about the main controls sending a data signal to call on that relay, well, then you could just unplug the data connection line. So it's just two wires coming in there. Just unplug that from the module, and then see if the pump relay drops out. Now you're going to trigger some alarms because it's going to see the module like lost communication and stuff. But ultimately, like if the relay really did weld stuck or failed closed, then unplugging communication to it or pulling that ribbon cable, something like that, should technically just completely shut that module down, which at that point should default back to normally open like those relays do. And if that doesn't happen, then that's just further indication that is for sure the relay. Now, I'm going to warn you though that sometimes just messing with stuff and jiggling things around causes stuff to move, and like the process of unplugging that ribbon or unhooking that data communication, it may have had welded contacts, but just you jarring the control module trying to pull on the wiring very well could have allowed what little bit of, say, weld, let's say it welded and arced internally and caused it to stick shut, you may allow that to break free and open up again. So then you hook everything back up and it starts to technically work. When in reality, the process of you trying to troubleshoot actually caused what is now an intermittent condition, and you still have a bad relay. So you may blame it on software at that point, right? So because that would be the next foregone conclusion is, okay, you disconnect, relay opens up, pump shuts down. Great. Well, obviously if you're going to go that far, the next step would be, well, I'm going to try to plug it back in and just see what happens. So you plug it back in, and now the pump starts to cycle like it's supposed to cycle. Well, so now you've put yourself in a position that, is it software that caused that, or was the relay bad and I just jostled it back open? Because that does happen. I've absolutely had this happen. You sit there and tap on it and it opens up again and it starts to kind of work again. In my book, that's still a bad relay. So in that scenario, agree with me or not, my default would end up being, okay, I'm just going to replace this module and not risk that relay. And to me, I've had far more scenarios where the relay was the problem versus something else. And if you are going to condemn the main board in that scenario, like, you've now significantly increased your cost of repair. That is a way bigger job, a lot more expensive. Programming and all kinds of things go into this than just swapping out that I/O module or swapping out whatever module it is that relay is connected to. So I don't know, just my thoughts on it, and how I would approach that. But it is a good point. Like, these are good questions. These are things we should ask. I'm not condemning you for having the thought. I'm just sharing my perspective, and we're just having a discussion on how I think about it. And you can take whatever away from that you feel like you need to. Okay, I'm not saying I'm right and this is the only way to do it. I'm just suggesting that if I was the one literally standing there, when I have done this, when I have been in that position, this is the way I've gone about it, and that's the decision that I've made in the moment, and it has served me well. That doesn't mean it's going to serve you well. It just means that it served me well. Yeah. Anyway. Let's catch up on starting up a flooded chiller. Got a vacuum down to, oh, so you're still on that one you were using the cold trap on. Y'all got it down to 138 now? There you go, man. It's exciting. How many hours or days? Let's count it in days. How many days total did y'all end up having to pull that down on that machine to get it fully dehydrated? I'm very curious. If you don't take unnecessary risk, your chances of something potentially going wrong. Yeah, exactly. Yeah, going back to the freeze and evap. You still charge the vapor. Hey, doing the vapor thing is such a great move, especially on flooded evaporators or falling film evaporators and such, where we have our greatest risk. Doing a vapor charge first and then following up with liquid, it's just such a great move. Do I always do that? No. Like, there's a lot of machines that I will just go dump straight liquid into. But this, again, the context becomes very, very critical here. So we're discussing a air-cooled style machine. I'm not going into the evaporator with that refrigerant. I'm going into the liquid line in that case, where these other, like a water-cooled flooded, I'm going into the evaporator with that refrigerant. But in like an air-cooled, a standard air-cooled with like a DX or braze plate, like, I'm going into the liquid line. So yeah, it gets back into, there's so many ways to do things, and it's not still wrong. It's just choice. Despite what many people may try to argue many times, it's just choice. You choose that, I choose this. Let's just get over it. Neither one of us are perfect here. And I'm not speaking to you, Jason. I'm just talking in general. But yeah, I doing a vapor charge is a great method, and I highly encourage it. Yeah, I appreciate that. Autocost. Yeah, I really wish YouTube would switch back to letting me like just see your name that you put in, not the whole at thing. Because anyway, I appreciate it, bud. Good to see you in the chat. Don't want to ask an off topic, but do you have any recommendations for chillers or electrical troubleshooting of residential and commercial HVAC chillers? It's not off topic at all. I'll take a second to kind of rant on that real quick. There's no off topic here. We are here to discuss HVAC, and more specifically, like, you'll get my primary background is in hydronics and in chillers and doing that work. And while I've got all kinds of experience on RTUs and splits, and I've done all that, I did residential before I did anything. So we can discuss some of those things. It's fine. It's not off topic, right? And just chillers is, I want a space where we can just come and ask genuine questions, and specifically around chillers, because there's just nowhere else that you can go do something like that, and especially do it potentially anonymously. Now, you can come in here, have an anonymous profile that I have no idea who you are and nobody else does, and ask a real genuine anonymous question and get it answered, right? That's the point of like this stream and doing this once a week and just having a space to have these discussions. It's really, really important that you have access to something like that. And I firmly believe in that. And so we're here to do that. And there's no stupid questions. Like, there's no dumb, there's nothing like that. There's been many times I've sat here and just explained what saturation even is. All right. And I'm okay with that. That's a great question. And it's a great question largely because, in my opinion, it's something that, whether it wasn't taught as well as it could have been, or we weren't ready to fully understand it and grasp it when we were going through some kind of trade school. That's saying you even went through a trade school. I know many of you guys got into this industry and never even went to school for it. You had to learn all this in the field. Okay? Some of the best technicians I've ever worked with never stepped foot in a trade school a day in their life. They are 100% field taught, but they put the work in and they're freaking phenomenal today. So, I'm just saying, there's no stupid questions. Let's just ask them. Anyway, to your point specifically, book recommendations. And you're saying on residential or commercial. So if we're going to get into, in terms of commercial, even just in general, the IOMs are genuinely the best place to go. And keep in mind, like chiller IOMs and such are not the same as what you'll see in like a split system or a small RTU. Many of those, they're not much more than just an install manual, quite literally. That's about all that they're good for. Is once you're past installation and commissioning, they're not useful. But that's not true for how chiller IOMs and stuff are written. All right, that's install operations and maintenance manuals, or even if you can get your hands on service manuals, if that machine has any. Not all machines have a service manual, but for the ones that do, like, those are great sources. Now, that's going to tell you about that very specific machine. Residential, we don't see, unless you're dealing with like somebody's mega mansion or something along that scale, we don't see too many chillers in the residential space. That might change with years to come, especially now that we have hydronic VRFs coming into the market, and people have gotten more and more familiar with geothermal systems. So using ground loops and stuff. Well, in many of those cases, those ground loops are actually just little water or glycol loops, and they're running through a heat exchanger back at the outdoor unit, right? So it's a very contained system. So as we are seeing more and more hydronics get introduced into what can be residential scale systems, I think that we are going to see this change with time. We may not see 100% into hydronics, and so hydronics is using water or a fluid to do work, right? So when I say hydronics, if you're not familiar with that term, that's what I'm saying. We'll just keep it simple with water to move heat. So a system that uses water in any capacity to move heat is a hydronic-based system on some capacity, whether it be on the condenser side, evaporator side, both, doesn't matter. It's a hydronic-based system. So, yeah. The IOMs are genuinely about the best I could offer you. There's not much on the market. Now, I've got my certification course. I've got my free course. You can go check out and learn all kinds of things, but I'm going to teach you chillers from a commercial, heavy commercial and industrial perspective. I'm not going to teach you from like a residential perspective because we just don't see too many in that application. So, yeah. Just trying to think. Like residential. Yeah, there's just not that many. I don't have any good directions to point you in, bud. You yank the board and replace it. And desolder the board and relay, get a new one, solder it back on. Yeah, and I will say, you have to be careful with the soldering stuff. It's one reason I did back off on that myself. So every component has a UL listing. It's got a safety listing. Now, in a scenario where you've got a genuine emergency, which you point that out, Jason, and you just need to do a temporary, hey, we're going to put this temporary one in until we get a proper one. Now, the trouble is, do you trust that customer to actually do that? But once you desolder and resolder back onto that board, you've technically, from the research I've done on this and talking to people about it, you've technically voided the original UL rating of that module. And now you are taking personal responsibility for that module's integrity. Well, what that could mean, though, is if it was a scenario where that module fails and causes a fire, and in the fire investigation, they find that that particular module was potentially at fault for causing the fire initially, whether you made a mistake or not, it's not the point here. It's just you worked on that module, you repaired that module. It's going to come up and the lawyers start talking to people that, hey, you worked on that unit, and that wasn't a factory UL UL, or that module is no longer covered under factory safety ratings because you modified the module yourself, right? And you start getting into this absolutely ridiculous legalese stuff. I'm just saying that folks should be cautious with doing repairs and then using those components in the field, and just understand that some of the legal aspect of this, those repairs can lead to trouble long term. Now, what are the chances of this actually happening? To be frank, really freaking slim. How many times have I done this myself in the field? Quite a lot. I actually carried a soldering station in my truck. I can't tell you how many systems I've walked up to that those modules aren't even available anymore. You can't even purchase them. You can't even have them refurbished. Like they're not supported. But this machine's got to turn on. We got to do something. So we either change this whole panel out, or I go down. Well, at the time I could go to like Fry's electronics store. They're shut down now. I don't know where I'd go now. I think I'd have to order it online at this point. But you could go down to the electronics store at one time and pick up a couple of components and solder it back on and get the system back online. And I've even had it happen where we had the solder joints on some of the little microcontrol modules on the board itself, just for whatever reason, came loose, and they weren't making proper connection anymore. And all it literally needed was just to be heated back up, and a little fresh solder reapplied, and it would reattach, and the board went right back to functioning normally. I had that happen on a McQuay self-contained. Old system no longer supported the control module was no longer supported. We had a failure on the display, and it was literally just that. The one of the IC circuits had a couple of terminations that had gotten disconnected, and we pulled it off and was just looking at, like, why did this thing fail? And it was having this weird intermittent thing. You kind of move and tap, and stuff would like flash. Weird stuff happening. Anyway, so we pulled it off, and I saw those loose pins on the IC controller. That's redundant. I know, integrated controller, IC controller, da 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 da. Anyway, so I just took it down to the truck, pulled the soldering iron out, redid the pins that were coming loose, put it back in. To my knowledge, that machine's still running to this day. So I'm just trying to point out, don't go complete cowboy with it, because you could and you are taking risk. And if you're comfortable with that risk, then by all means. Just, I don't want you to be blind to the risk and then somebody come knocking one day and you just not know any better. Because, yeah, if nobody ever told you, it doesn't remove the liability from you just because you didn't know. That's the sad part. I see. Yeah, take the menu boards off. The failed desolder. Yep. Yep. As long as you're good with the liability. The liabilities of leaving field repair boards is not an option if the customer doesn't want to pay for the new board. Yeah, so Jason already ran through all that in the chat. I only read his first comment and took off, but that's the risk, though. It's like, some of these customers, will they actually pay to follow up? And because then you've got to go back out there and take the repaired board you put in back out, and like, it just becomes this whole thing, right? And the whole time that module's in there, your liability is on the line, right? That's the tricky part. So you really have to trust a customer if you're going to go that path. When pulling a vacuum on a service valve, stem, and packing, how do you move the stem to charge without compromising your vacuum, moving the packing? Oh no, hang on. Oh, we just had a grass fire coming. Where's it at? Give me 1 second, guys. 2 callers, no longer on scene. Where are we at? Okay. Stations, we have our central, which is what I serve out of, and then we have a west station. That call is for the west station. So I don't have to respond to that one. Yeah, we had a fire. I had 2 fires yesterday. And the one I did make it to, yeah, the guy had some burn piles. We literally just lifted the burn ban 2 days ago. So the day before yesterday was when they got lifted, and then yesterday we had multiple grass fire calls from people letting their burn piles get away from them. Anyway, I'm sorry. Getting back on track here. Okay, let's pull this question in and let's talk about it. Just give me 1 second, get everything set up here. All right. Okay. When pulling a vacuum on a service valve with stem and packing, how do you move the stem to charge without compromising your vacuum, moving the packing to adjust the stem? It will suck in air. Yes, absolutely. The way I've managed this is using isolation valves. So I will set I'll set the service valve where I need to, and then I'll have to use isolation valves from there. Now we'll get to that in a minute. So that's really the only, because you're right. The moment you pull the cap off, because what I would do in that scenario is you get it mid seated, and that opens your service port so that you can pull the evacuation and then later charge. And then I will put some nylog on that cap, put the cap on, make sure it's nice and tight and fully sealed as much as we can, within reason, and then pull my evacuation. And then from there, unless I just absolutely have to, I will not touch that cap beyond that. So, having an isolation valve, like a core remover tool, as an example, and that's assuming you're pulling through a 1/4 inch valve, right? So if you're doing like a 1/4 inch, I put a core remover tool on that and isolate that way. And if I'm pulling on a larger circuit, so let's say it's a 3/8 or up, you really kind of get into this, well, this just sucks kind of zone, because we don't have good options for isolation valves at that service at that low of a level. So you've got a couple of things that you've got a couple of things you could do. I'm trying to think. I don't want to. I've done some pretty wild stuff in the past, just trying to make things work, and so I'm trying not to give those recommendations, because, to be frank, I don't know that I would do that again. I've had lots of scenarios where I just had to deal with it, to be honest. So I've had plenty of scenarios where once you finish the evacuation, it was larger ports, isolation wasn't an option, and it was either go with the larger hose and get it done faster, or put smaller hoses on and put reducers and have isolation that way, which I've done plenty, right? We've got some pretty decent hoses in the market now, to where going from a 3/8 to a 1/4 to then a 3/8 or 1/2 inch hose into a 3/8 or 1/2 inch port on your vacuum pump. Is that great, or is that a good direction? No. Is it better? Is it better than pulling in atmosphere when you don't have an alternative option? Yes. I've had plenty of scenarios where I've had to go to the larger port and not have an isolation, and just had to accept the amount of vacuum I'm going to lose by having to use the port. And it just sucks, and I didn't like it, but that's what the option I had at the time was. And that does affect, like, there's problems with that process. I mean, obviously so. And I don't have a really good, but I don't have a very good solution. Now, here's something I will offer that I do before I do this, and that is service the valve stem. So when I have a service valve that, and I've got so I actually had a prop. So I've been waiting on this question to come in one day, because I had a prop right there. I was going to pull down. I was going to do a whole spill on this, because it's a thing that I like to do. And the question finally comes in, and my prop's out in the trailer. Anyway, so what I like to do is I take the valve stem, but this is before I do anything, okay? Before I even before I start to pull the evacuation. Let's say I just finished pressure testing. I'm going to make sure the stem's fully backseated. I'm going to wipe it off with a towel and a rag, and I'm going to put some nylog on it. And then I'm going to front seat it. And I'm going to backseat it. And depending on the condition of the grommet in there, one of two things could happen. Either it's going to come back completely dry, the stem will, so all the nylog I put on the stem just before I ran it in got trapped and honestly used inside of the the packing, or it's going to come back out and it's going to be black and dirty and nasty. And either way, if it came back out dirty, I'm going to clean that off again, put a little more nylog, and I'm going to go back in. If it came out dry, like all the nylog literally just went in there, got stuck, and didn't come back out, which is fine, I'm going to put some more nylog on it. The whole point and goal is for reconditioning and cleaning the grommet seal inside of that valve, just to minimize what we're discussing, right? I want to have minimal infiltration once I need to start working that valve, if I think I'm going to need to at all, like if it's one of those scenarios. And so you may cycle that valve in and out 10, 20, 30 times. I don't really care how much I have to do it. I keep going until the valve shows nice, clean condition. So when I start running it in and out, and I've still got clean nylog coming back in and out with it. So with each time in, then coming back out, that nylog is staying clean and not showing a bunch of debris and contamination. Like, you'd be surprised just how much crap starts to come out of there. And part of the issue is those grommets with time, especially if they're on the high side of the system, like they will get very dry, and they can get it can make it hard for them to seal properly, even if you were to tighten the packing nut. And so that's where I like to go through this reconditioning process of that nylog gets in there, that it begins to soak into that grommet, and it'll help recondition and get some moisture, get some life or some oil, not moisture, but oil back into the grommet, help it seal better, help it reseat. And then all the black stuff and all the junk coming out of that packing is just years of that say grommet and just whatever oil, whatever material in the circuit and the grommet itself or the packing itself has just gotten stuck, where it's just kind of hanging out right there on the grommet surface, and it's not allowing the grommet to make as good of contact with the stem itself. So all of that gets in the way, and we're starting to talk about like deep vacuum levels. That's all it takes to really screw some stuff up. So yeah, I'll go through an entire reconditioning process and cleaning process on that valve. And in that process, that's when I've been able to use the valve and it doesn't eliminate the problem. It just makes it far less, in my experience. I have had far less issues reconditioning the valve and then using it for my evacuation if I want to use the 3/8 or half-inch port that valve has. Really, really helps. If it's a 1/4-inch port, honestly, it's just not even that big a deal. I still recommend reconditioning valves. Don't get me wrong. Highly recommend it. But you can just put a little isolation ball valve, like I don't really care which brand you go with, right? Navic, Appion, just pick one. But you can put that on there and it'll isolate that way. But anything larger than a 1/4, I'm going to recondition. You don't have to necessarily do nylog. You could do just the compressor oil. Make sure it's fresh, clean oil, right? It's new oil that matches what goes in that circuit if you're going to go that path. What I like about nylog is it is thicker. It will help kind of get more of the debris and the trash to dislodge, in my experience. Like I said, though, you can use the compressor oil to lubricate, recondition, and help. But that compressor oil, one of the issues I find with it is it won't do as good of a job like sticking to the packing material and helping it recondition, because it's just a different material. It's not the same thing as nylog, and not everybody is a fan of nylog, but that's one of the properties about it that I appreciate, and I find it really, really works well in that environment. So yeah, it's a really long-winded answer to how I've had to manage that. And sometimes I just feel like, okay, well, it's the best I can do. I don't have alternatives. I've got to make it work. Is it by the book? Is that correct? Maybe not. I don't know. but it's what I had in front of me and what's what the options I saw at the time. That's my mentality around it. Are there any other options to pull data from carrier chiller to any custom dashboard? Yes. Yeah, on the so carrier you can use, was it carrier net? Is that what they called that? Carrier net? Comfort net? No, not comfort net. There's something net. I forget the actual name carrier used offhand, but basically they have, I think it's you can use, I think, backnet or Modbus technically. But you there's a, let's see. I know the RTUs, we had to use a COM module. Yeah, same thing on the chillers. When I've had to do this on the chillers, we use a COM module. So it's a special just communication interface that will translate what the chiller control boards, like internal communication, will, it translates that communication data into a standard protocol like Modbus or BACnet, to then other systems can connect and communicate, and it acts as just like this translator in between other equipment and the chiller's internal controls. Now you can connect, in many cases, you can connect like a carrier chiller to a carrier chiller or something like that, and they can internally communicate just fine. But when you want to bring in Modbus or BACnet, that's where we usually have to have a communication module for standard protocols. It's not built in. A protocol is basically like a language we speak, right? So it all may be some version of RS-485 or otherwise, but the specific language being talked over that serial bus, 232 or 445, pick one, the language being spoken is the protocol. That's what matters. And even inside of those languages, there can be different, call it dialects, where there's slight differences. So like there's a couple of different versions of Modbus, and anyway, without getting too off into the weeds, you would just need that. If you get the module, communication module, you can have it set up for whatever you need, Modbus or BACnet, and then that'll pull back into whatever dashboard you're trying to use for the customer. If the system's already connected to a automation system, like a BMS from a controls company, even if there's not a dashboard, like a front end that the customer has, but if they have building automation that is actually talking to the chiller, not just sending it start stops and like receiving outputs from the chiller, like alarm outputs, but actually has a data bus communicating with the chiller, well, then you already have a COM card in there, the COM module. It's just a matter of tapping into that network and sharing part of that data, and you could pull points in from there and do what you need to with it. Oh, that is true. The Electricity for Heating and Commercial Air Conditioning by Bill Russell. That is a phenomenal book right here. I guess I don't think about these enough or give them enough credit. Like, so this is the electricity one. Absolutely phenomenal book. I don't know why I didn't make that connection earlier. This would be a good one to recommend. This is an older version. I think they're on much newer ones now. This is the 9th edition. I don't even know what edition they're on today. And then they do have a chapter or module that, yeah, I think they've got a module in this book for discussing like hydronics and chillers and like heavy commercial type stuff. It's pretty limited, right? But it's a good, like, if you're just looking for a really fast, let me get my head around this, it's not a bad intro. It's just limited, and that's not the focus of this book. The focus of this book is to cover like the foundation of the industry, and they just kind of talk about the heavy commercial stuff. Yeah, really, really good book though. Thank you for pointing that out. These are if you're going to invest in a couple of books, these are 2 books to invest in and spend time. Now, they're no joke. This is going to take some work to get through these, but phenomenal books. Over there for now. Can you talk about the modern turbo core compressor that uses magnetic field technology and is oil free? Oh yeah, you want to talk about turbo core? Let's talk about turbo core. I love talking about turbo core. Turbo cores are so much fun. They're such incredible little machines. All right. I'm going to do that different. See if that's better. Can you talk about the modern turbo core compressor that uses magnetic field technology and is oil free? So, yeah. This is a centrifugal compressor. All right. So let's start off with that. We have a tool called the Turbo Tool app. This is a fantastic app to really just get familiar with this compressor, even if you haven't put hands on one. Let me show you here. So this is the Turbo Tool. This is an app you can download on any device, Android and Apple. Pretty sure they have an iOS version. I'd be shocked if they didn't. Pretty confident. Actually, they have to, because on my hands-on classes, I have everybody download this that doesn't already have it. And there's plenty of iOS guys that are able to get it just fine. Anyway, you can just do so much to get familiar with this compressor. So this is Turbo Tool by Danfoss. All right. Really handy, not only from a field service perspective, but also just learning. They've got all these videos. You can pull manuals. Like, there's just a lot in here. They really do a good job. Daikin did a good job setting this up to teach you how the turbo core worked and functioned. Now, some things to discuss. Yes, it's using magnetic bearings, not physical bearings. So what that looks like, we can come back over here. We have our bearing, okay, but this bearing actually has a set of coils. Okay, and our shaft is here in the middle. So this is our journal. Okay, and we've got this ring of coils on either surrounding the bearing, and essentially what we're doing is we've got a control module that is increasing or decreasing the magnetic field around each bearing in order to maintain a very tight tolerance where the center of this shaft just barely even moves. I mean, it stays right on where it's supposed to be. And we have a lot of sensors in the system, like monitoring where we have the ability to sense where this shaft is at any given time. And so the system is making extremely fast adjustments in order to maintain its radial position. That's one of the things to keep in mind with magnetic bearings. Have a similar issue to what we would call a hydrodynamic bearing. Okay, so your journal bearings, the sleeve bearings that we would use in other machines. If that doesn't mean anything to you, it's okay. You don't have to know what that means right now. What I'm saying is, we have good radial loads. Okay, so your radial loads are the loads coming in from left to right or up and down. All right, those are radial loads, but not your in and out. So a load that's coming in like this from the end of the shaft, pushing the shaft through the bearing, a radial magnetic bearing doesn't do a lot to help you. And that's where we have an axial bearing. So let's just say this is our shaft. Okay, so we have a front radial, a rear radial. Well, then we're going to have a rear or we're going to have a axial, I should say. So it'll be some kind of axial bearing. So there'll be this metal plate or ring on the end of the shaft in a turbo core specifically. There'll be a plate back here and a axial bearing that controls the in and out, right? And so that's where we get all of our points of axis control. We have our radial control and axial control. Other compressors do this slightly differently, but you'll have your centrifugal impeller out here doing its thing and driving the compressor that way, right? So let's see, what can I tell you about turbo cores? If you have more specific questions, I'm happy to get into those. I'm just kind of talking about them from a general sense. One of the great things about the magnetic side of this is we don't need oil anymore, because we do have what's ultimately a frictionless bearing system. So with regular bearings, we need oil to lubricate the bearings so we don't tear them up. In this particular case, the shaft is literally floating. It's levitating is the term we use, in air or space, since technically we're in a vacuum environment, but we have refrigerant in there, so it's not air in the system, it is space, but it's not technically a vacuum because we have refrigerant. Anyway, I'm just goofing around. Okay, so the shaft is just floating in place. So that by removing the oil, see, the issue with having oil in a system is it removes efficiency, because it gets on our heat exchanger or in our heat exchanger, and it reduces the amount of heat transfer we can have, because oil acts as an insulator. So if we can remove the oil entirely from the system, we now have that refrigerant able to make literal direct contact and not have an oil film. Despite how small of a film, we don't have no oil contamination in this machine interfering with our heat exchange at all. And that's exactly what we want. And it's how we maximize the efficiency of these machines. The downside is you have to have dedicated equipment for that. So you need a dedicated set of tanks and machines and hoses and everything. Like, you cannot get oil in these. More than you don't have oil, you cannot get oil. And the reason for that is the bearings. It all kind of comes back to the same root thing. So the bearings on these, if they get oil coated on them, it will end up shorting out the bearing and causing a failure. So that's something we have to take very, very seriously. Majority of the compressor failures I have seen have been because, or bearing failures have been because somehow oil got in that system. Whether it was a retrofit that wasn't cleaned properly, which turbo cores get used for a lot. They do a lot of retrofits with turbo cores into what was, say, a screw compressor. They're now going to convert it with, say, like a TT350, which is a high lift version of the turbo core. But it's small enough that it can match whatever screw compressor was in its place. And so it's just got this nice little sweet spot. Anyway, but then they don't clean the oil out of the system properly, and all that hits the compressor and fries the compressor. Or a service was done on a machine from, let's say, the recovery cylinder they used had oil in it, and they didn't know, and they put all that back into the system. And now they've got a oil contaminated system that wasn't supposed to have oil at all, and that oil is going to eventually make its way back into the compressor, and that's going to cause ultimate failures on the bearing side. So the vast majority of the bearing failures I have dealt with have been oil related on some degree. Let's see, what else can I tell you about? Oil free, heat exchange, can't have oil hit the bearings. We use magnetic fields. We're monitoring the fields. Radial load, axial loads. What do you want to know? They've got a built-in VFD. Yeah, so the drive system is built in, which is unique to the turbo core. Well, okay, let me back up before Jason gets me. There are other compressors on the market that have a built-in drive system, a VFD onto the on compressor VFD, but TurboCore was one of the first compressors we've seen really do that effectively, that has actually stuck, and it's been a core feature of the TurboCore for a long time. So the actual whole, now we're talking the TT series and TG series specifically. There is other series that they've come out with that don't have an onboard drive and control assembly. Everything is separate control panel, but in terms of your smaller TT and TGs, everything is built onto the compressor body, which is fine, and it actually works really well. You just have to be careful and understand that it's different. So you can't go pulling panels off on a TurboCore like you'd open a pecker head on something else, because like you are opening that live drive and it needs to be in a secured place so that everybody stays safe. But you've got an entire drive system up there on top of that compressor, in addition to the backplane board, which is where all your control modules are. Really, really easy compressor to service and take care of. They have a service software called SMT, Service Monitoring Tool. Again, you can download that on the TurboCore website from Danfoss. It's free to get. It's fairly easy to use once you have learned how to set it up and configure it. It's pretty easy to use from there. If you're not familiar or you're not very techy, it might be a bit of a challenge your first couple of times, but then you'll get the hang of it. Of course, then you need the service access code, so there is that too. Let's see. What else can I tell you? Yeah, I mean, without just having something more specific to dive into, that's a really high level, just some how a TurboCore is laid out, some specifics to TurboCore, yada, yada, yada. I can always go deeper if you have a more specific question about them. We can go from there. All right. Yeah, CCN, Carrier Comfort Network. Yeah, but their actual... that is what they call it, but they have an actual the actual tool, like the network tool that you use, because like for those carriers, in order to communicate with the software, you have to have their little comm module that plugs in to the computer. Now, if you were going, okay, let me rephrase. That's if you're trying to configure and program. You need that module to talk to the unit controls. If all you're doing is pulling data points, you do not have to have that module. You just have to have the comm module, not the service module. So the service module is what you need to pull, like actually get in and review configurations and that kind of stuff on the back end. So that's fair. Yeah. So see, okay. Yeah, you need the CCN comm module from Carrier. You're not trying to get into the service side of things. I'm replacing burned out screw compressor contactors tomorrow. It always makes me a bit stressed. Always check everything a few times. Yeah, just trying to get everything. Make sure your torque specs are good. Using the good old, torque wrench, right? Hopefully. Yeah. I will say the bigger the starter gets, the more intimidating it can get, for sure. And it's like, okay, if I don't put this in just right and this goes to hit and something doesn't line up just right, there's a big kaboom coming after that. Whoops. All right. When can we replace oil compressor? Train RTAC. Tell me by eye if oil needs to be replaced. Okay, yeah. Really good question. Let's get into this RTAC oil question. Get it booted up here. I wish there was a easier way to just like plug and play this. I didn't have to like kill 30 seconds every single time, but I haven't figured one out yet. When can we replace oil compressor? I think you mean compressor oil. So just so everybody's aware, and it's not a problem. Just some of these questions are run through translators, and those like English is different in how they like. I think of this as like English to Spanish. Okay, so sometimes the words can get switched around because of how the language contextually organizes the sentence. And so anyway, so when can we replace compressor oil, train RTAC? Can we tell by eye if the oil needs to be replaced? What does it look like in that case? Yeah, so the oil is going to have a dark tint to it, right? So the longer so fresh oil is going to be fairly clean and clear, right? It's not going to have that much color to it, right? So it's not that it has no color. It's just it's a fairly clear color, right? It's not that bad. As oil gets hours on it and runs, it will slowly start to get this more of an amber color. And so it starts to just look more and more like it'll probably start off as it starts to age. We can use beer as a good guide here, right? So you get into like a really good light beer scenario. It's got kind of this yellowish tint to it and stuff, but in that condition, it's probably still fine. When you start getting into the zone when it starts to look more like a really really good darker amber, okay, a good amber beers. How those are some of my favorites, and so by the time the oil looks like something I'd like to drink, that's when it's like, okay, something's going on here. So a darker amber tone is what you're really looking for. Now, another indication is how thin does the oil feel, right? Now, if you start getting into dark beer, so beyond amber into just like legit dark, where it just it's hard to even see through it because it's gotten such a dark tone to it. That's when you're in. Okay, this has to be changed out. This oil is really starting to break down. You've pushed way too far at that point. But even by the time you start turning into just an amber, that's when you really want to get that oil change, because it just that color change is the wear and tear and the age of that oil as it's staying in the system and as it gets more contaminants in it potentially. And that doesn't mean like metals and acids, like I'm not saying that kind of contaminants, but just as that oil begins to age and break down, I'm not going to use automotive oil as an example because a lot of what darkens automotive oil is the carbon that gets in it from just the combustion cycle. So it's not really a great comparison, but in a conceptual way, the same way that as automotive oil darkens with use, not because of we're not getting the carbon from an engine burning, but we are getting some darkening because of just wear and tear. So that's really what you're looking for, is the darkening. Now, how thin and it feels is also going to be important. Keep in mind, you have to be careful of this. If that oil is at operating temperatures, which is going to be somewhere between probably 100 to 150, 60 degrees, somewhere in there, it's going to feel thinner than, say, room temp or ambient. So if you've got an 80-degree day or whatever it is, ambient, and your oil is at ambient temperature, your new oil, you doing a viscosity comparison, how thick it is between the new and the old, is not going to work out, because the existing oil in the circuit's automatically going to feel thin because of its temperature. Now, if you take some of that oil out and let it cool and come to ambient or get closer to it, then feel the viscosity, you can get a far more realistic feel. And that's assuming that you don't have a feel for this already. So when you're first starting, and you haven't kind of gotten a feel for what you're looking for, that's what I recommend. Let the oil cool down and compare what the new oil feels to what the old. And I just put a bit of it on my fingers and I just rub it around and I feel, how thick is this? And can I see like the oil beginning any evidence of separation, or is there any kind of floaties messing around in there? Like, you're looking for trash, you're looking for debris, and you're looking for the viscosity. Now, as you get experience and such, you'll begin to realize, or you'll begin to train your senses to understand oil at operating temperature. This is how it should feel, right? And you'll begin to recognize, okay, this feels far more watery, far looser. It's not as thick. And that's what you're looking for. Once that oil begins to get much thinner in viscosity, its texture, it doesn't have the same thickness like you would expect it to have even at operating temperature, you that is an immediate indicator that oils began to break down. And part of what will happen is the actual compounds in the oil begin to separate. That can happen with too much heat. So if you're running a really high discharge superheat, that's going to cause the oil to begin to overheat. If your oil level's too low, or your oil cooler is not functioning properly, and you're running high oil temperatures in any way, like not having enough oil in the circuit can cause that, because the same oil is having to recycle too quickly. It doesn't have the same time to cool down, right? So there's the oil running hot will cause a lot of breakdown in that oil beyond just like debris and trash getting into it. So we have to, these are things we're trying to control and monitor for. And then you can feel that. Sometimes you can just see it. Like you can get an oil sample out and just look at it, and you're just going to see beyond just color. It just doesn't look quite right. But then you'll feel it and you'll really see the texture difference. So that's just, now I see in the chat, like, laboratories, absolutely. I'm getting to that point. So I'm coming from an approach of, we're in the field, we're looking at this circuit in this machine, and I just want to get a sense of where am I at, what condition is my oil in. So I'll get a small cup, a clean cup, take that, just a small little sample from wherever I can out of the circuit. Like at that point, I'm just trying to see what oil looks like from anywhere. It's best if I can get it from the reservoir, right? Wherever that is. If that's the oil separator, if that's out of the compressor in an RTAC, in your case, we're discussing it being in the oil separator. So if I can get a sample out of the separator, that was the best place for me to get it. Which you do have a service valve at the bottom of that separator. Even if you can't quite see it, it's tucked up underneath there. That's what you're wanting to use in order to get that sample out and compare it. And again, so just before we even get to the point of having a lab look at it, I don't need a lab to look at it, in my opinion, if I have dark ambering, if it's gotten really thin viscosity or began too thin at all, right? So if we're just thinning, except by the time we are thinning, and I've got color change, it's just time for that oil to be changed, period. And if there's any heavy debris, so if I'm pulling that sample out and I'm getting debris out, now if we're dealing with metal flakes, that's a big concern. Okay, we could be discussing bearing issues at that point, and there's other troubleshooting that can be done. But if what we're seeing is just if we're just seeing debris coming out of that oil, it could be that there's acidity or other stuff happening, and that could be part of the we call it sludge that's starting to form inside the circuit. We need to get all that out. So you're talking about an oil change regardless at that point. But if I'm seeing those other conditions, I want to get that I want to get a sample sent to a lab either way. And so this is where we get to the lab part of this, and that's saying that you have labs available to you. So I know there's lots of parts of the world where you may not have a lab. So here in the States, what we would use like my preferred would be United Refrigeration's what they use, NRI Laboratory. They sell a kit you can get. It comes with a FedEx label and stuff. They're not the only ones. I know Train does it and such. I have preferred the NRI kits personally. And I just do all that through United Refrigeration. That's what I would do here in the States. Now, internationally, that's a different story. It's really going to depend on your area, and I don't have a recommendation for you at that point. So if you don't have a lab available, then checking with color, viscosity, and just looking for debris or material getting into the oil that you're pulling out of the reservoir, these are indications that you can use to know, okay, it's time to change this oil or not. And again, I do like to use beer, like a beer color chart for that, because new oil will look like a really, really light beer, like a super light beer. It'll be fairly clearish in color. It shouldn't have any kind of smell to it. And as that oil begins to break down, it's going to continue scaling into darker and darker beer. Like I said, by the time I'm getting into amber stage, I want to look at changing that oil. And if I have any kind of smell coming out of that oil, like an acidic smell or a burnt smell, something like that, time for that oil to go. If as that oil begins to get thin and it has visible signs of it breaking down, time for it to go. And then anytime I have debris. And these are true without even needing a lab to tell me anything. So when I have to use a lab for full analysis, that's where I get into, okay, the oil itself doesn't look too bad, but I do still want to see what is this oil condition, because you could still have acidity, you could still have issues and metal flakes in there that aren't visible because they're so small, with clean, what looks to be clean oil and fairly fresh oil. And I say fresh as in it's not been broken down. It didn't have a lot of wear on it. So it may be just a slight yellowing or something like that. That's where a lab can come in and give some really good feedback on what are the actual particulates inside of that oil. And then you can make better decisions from there. Yeah, hopefully that's a sufficient enough answer to get you where you need to be. It would take me a minute. I do have some pictures of like some examples I could pull up, but I don't know that it would take me a second to get that pulled up and show you. Let me see if we have another question in place. Yeah, take oil sample laboratory. Yeah, if you filling the oil, return, check as needed. Analyze, tested prior to lab. Yeah, I've always done those oil samples on an annual. And like I said, now on a quarterly or something like that, that's where if I've got a machine that I'm worried has an issue, then I'll take the time to do a more frequent analysis. But if I've got a stable system, it hadn't had issues, I haven't had any concerns with it, at that point, that's when I'll do that on an annual basis. And then if I do have a burnout and I'm having to go through a acidic cleanup process, that's when I'm going to want more frequent checks. So in terms of 10,000 hours, I've heard different things. Some I've heard 5,000. I've heard 10,000. So I mean, ultimately, it has a lifespan. Okay, it has a lifespan, and if you're monitoring it for hours, that's fine if you want to do that. There's lots of places that they change their oil every annual. Every annual. They're getting brand new oil put into that system. Now, to be frank, that oil, in many of these cases, getting 5 years plus out of that oil is probably not a big deal. There's plenty of machines that have been running the same oil for 10 freaking years. Should it be? Probably not, but it has. Okay. This is where I personally, unless it is a particular site, so we have applications, we have scenarios where it's a critical site. Okay, let's talk about power plants as an example, or a major manufacturing facility. Those types of sites can't cut corners. Not to mention don't, they can't. So those are things you're going to be changing that oil and such on a constant routine, regardless of its actual condition. It could be perfectly fine. They might not have put 100 hours on that oil, to be honest, but it doesn't matter. You're going to change that oil out. The risk is not acceptable, period. Outside of those environments, I don't really stick to a hard, like, okay, we're going to monitor the hours and at this many hours, especially when we have scenarios where, like, as contractors, we're constantly being revolved through accounts, constantly. And even as a technician, again, you're constantly being revolved through accounts. The days where one person took care of the same account for a decade or more, you just don't really see that the way I think we did kind of see it at one time, at least here in the United States. That's the environment that I'm used to seeing here now, where it's just a continuous rollover of accounts, and it is what it is. So in that case, tracking hours and having an hours log like that and expecting the customer to have log of that in most accounts, it's just not available, that kind of data. So I don't base it off hours. I've come back to, I base it off of the oil's condition. So when I see the conditions I described between the physical, what it looks like, the color, smell, viscosity, debris in the oil, it comes down to those things. And then also having a lab check if I can have that. I will does this oil need to be changed off of that? And here's some things to this that really add a lot to the conditions. A machine that is not being, let's see, if the discharge superheat for whatever reason, whatever's happening, if the discharge superheat is running excessively high, or that machine is running excessively high oil temperatures continuously, even if it's below the safety threshold, okay? So an RTAA safety threshold of 170 degree oil, well, if I'm sitting there constantly running at 160, 165 all the time and I never back off of that, I may not ever trip on oil temperature, but I'm still wearing the absolute heck out of that oil trying to ask it to run at 165 all the freaking time. And so that machine is going to break that oil down at an accelerated rate because the oil is running at such a constant high temperature. Now, it doesn't matter why the oil is. We can debate, negotiate why we're having a high temperature. Point is, we are. And so we may not even hit the recommended hours before that oil has already began to fail. And sadly, what happens so many times is before we actually address the oil issue, we let the compressor die first. And the compressor failing and this becomes a symptom of not keeping up with the oil. And the oil may be a symptom of something else, whether we had too little oil, whether the oil cooler was plugged up, who knows, right? Maybe we had some non-condensables in the system and it was just causing, who knows why. Maybe we've had scenarios where the suction superheat wasn't being controlled properly. We're running really high suction superheats. Nobody ever did anything about it. That high suction superheat was leading to high discharge superheats. That high discharge superheat was running high oil temps. That high oil temp eventually caused the oil to break down, which eventually circled back to having a failed compressor, which then led to a burnout. Well, guess what though? Now the burnout, like that one symptom, we have to backtrack through every freaking symptom now after cleaning up the acidity to get back to the original issue of we weren't controlling suction superheat. We were running really high superheats, and that led to the failure. So if we're constantly monitoring the oil and its condition beyond just a laboratory, right? I do not agree with just put it in the lab bottle and ship it off. In my opinion, and the way I train this, you need to observe that oil and how it degrades with time if it's an option beyond just the lab. You, the technician, need to be monitoring this yourself. You don't need a lab to tell you, because I've had plenty of scenarios where you could visually look at that oil and you could see it and you could tell it wasn't okay. It needed to be changed, but the lab report came back just fine. It's because from the lab's perspective, the oil didn't have anything crazy going on with it. It was still within specs. But you can visually look at that as a technician in the field and know that ain't right. So be cautious just relying on a lab report. Not saying that's what everybody is doing. I'm not making an accusation. I'm just stating my position on this. Let's see, what got me off on that tangent? The hours thing. So that's why I don't rely on hours. I rely on actual condition. Because if I'm not taking care of my oil because of temperature, then that's going to lead to a shorter lifespan. And if I have oil that's been extremely well taken care of, temperature's good, system's clean, yada yada yada, then I may get way more than the recommended hours and it'd be perfectly fine. So I adjust to the oil itself. What are the appropriate water pressures? Come back to that 1 second. Do you think an ultrasonic detector? Train tells you not to change the oil unless the oil analysis recommends it or overhaul. Right, and that's if you're going through Train's direct. That's just where I disagree with Train. Like, I disagree with Train on a number of things, like their factory recommendation. Now, again, I have to disclaimer up front. Listen to the manufacturer. It's their machine. They know, they stand behind their recommendation is what it is, okay? Listen to them. It's their machine, as in they made it, they designed it. I'm just a tech out of the field. Okay, now that disclaimer is out of the way, I don't agree with everything the manufacturers say. And there's plenty of times where, just from my own experience, this oil being an example, there's lots of times where I can visually tell that oil is done, even though the lab report says it's still functioning. And I'm just not going to take that risk. And I'm not going to recommend that risk to the customer. And so in those scenarios, I'm going to override Train. This is me personally. This is not me telling you to do that. This is me personally. I'm not going to override Train. I'm going to recommend the oil. And so you can track condition of your journal bearing. And so that's where we're getting specific now. Jake, you may not have caught we are specifically referencing an RTAC, but I mean, it's a fair point in terms of tracking your journal bearing, right? You can, because if you change the oil, you're not going to see your aluminum increase in the circuit the same. And so if your journal bearing is starting to have more and more excessive wear, that fresh oil is going to basically reset that meter, if you will. And that's a fair point. Like, it is a fair point. That's where you got to decide what are you trying to do. I take the position of, I'd rather protect the bearing by having oil in better condition than by letting the oil get to a severe condition, which then causes damage to my bearing. Especially if I'm not using Train's internal laboratory. Right? If I'm not using the Train specific lab, which I don't, I use the NRI lab, which I get through United Refrigeration. So I don't know. There's arguments for both ways. There is. I think it comes back to your experience, your site. How do you want to do it? That's not the way I do it. But how do you want to? I just have a different way of thinking about it. And I'm not saying that's wrong. I just have a different way of thinking about it. Okay, let's jump to, we got just a few minutes. Let's jump to this question. And I do save questions, by the way. So if for any reason I don't get to all of them, I will save them and we will discuss them at a later episode. So feel free to get them in, and we will circle back at some point. What are the appropriate water pressures for the chiller's water circuit, and should they be equal between the inlet and outlet pressures for AHU units? No, there will be a pressure drop. Okay, let me start with just the AHU piece of this. The coil should have a pressure drop of some kind. Now, it will depend on the coil and its design. I know, like for some comfort cooling applications and stuff, seeing a 10 psi drop is pretty typical, somewhere in that zone, 5, 10, maybe 15. It just kind of depends. And that's at full flow. Okay, so if we've got a variable flow control where we're modulating based off of, let's say, supply air temp for comfort cooling, then as we modulate down, we're going to see the pressure drop reduce because we're flowing less through the coil. But at full flow, valve at 100%, then that's where, seeing that higher range. So no pressure drop at all would indicate no flow to me personally. So if I don't see any pressure drop, then that tells me there's not flow happening here. That's what I'm looking for. There should be some kind of pressure drop across that heat exchanger. Now, in terms of appropriate water pressures, that gets back to the actual height of the loop itself and what it's designed for. These are things I go through in complete detail in my certification course at chilleracademy.com. So, like, understanding what your water circuit pressure should be. Like, I have an entire hydronics module dedicated to breaking this down and explaining the process. Really high level review here is going to be the height of your loop is going to determine things the most. So at the very, very top of your loop, wherever the highest points are, I like to maintain around 10 to 12 psi at the very top of the loop. Now, water has weight. So if I've got a multi-story building and I'm checking the loop pressure at the very top up on the roof, let's say we have a penthouse scenario, whatever the case, I'm up at the top and my loop goes all the way down, and let's say I'm at a midpoint in that, well, I'm going to have a higher pressure. So if I've got 10 psi at the roof, but I'm 2 stories down, I may have, 30 something psi. I'd have to actually run the math here, but because it's, you have 1 psi for every 2.31 feet of elevation, or we call it head, right? We call it head, but what we're saying is elevation. For every 2.31 feet you move up and have height of water, we have gained 1 psi. And the diameter of the pipe is not what's relevant. It is the height of the pipe. Okay, that is called head weight. So we have to calculate that in, and we can do that via feet. And so that's how you can run that calculation. So you could take your total feet, divide it by that, and then that's going to give you the psi you would expect for head weight. And then we want to add roughly whatever the pressure is at the top of the loop, add that pressure at the very top, because at the very top of the loop we have no head weight. We are at our actual, call it actual pressure if you want to. And then we have to add head weight on top of that as we go down in elevation from the very top. So you take your feet of elevation, get your head weight pressure, and then add your pressure from the top of the loop, and that should be the pressure at that device. Now, this is specifically honing in on the return side or the suction side of the pumps. That's where we're going to monitor and maintain this pressure. So you would expect even higher pressures on the supply side of the pump, that leaving the pump pushing out into everything. So the pressure coming into the AHU's coil is going to be higher than that. And then I'm discussing the pressure I want to see leaving that coil, coming back into the common header as we return back into the pump. That's the pressure I want to control. And I'm going to do that through a PRV, a pressure regulating valve, off of the domestic water lines typically. And then you'll also have bladder tanks somewhere, or hopefully you have some kind of bladder tank in the system, especially being a closed loop system, to control that. Now, there are open loop systems, okay? That's a whole nother ball game. That's probably not what you're dealing with because there's not as many of those out there. So just be mindful of that. If you're dealing with an open loop, those numbers change. That game changes a bit because we're not pressurizing the loop the same way. But if we have a closed loop, then we will have a pressurized loop, and all the head weight calculations, all that comes into play. So that's how that's how you will determine what your pressure is, and is it where it should be. So if you're at that midpoint in the loop and you run that calculation and that number is too low. Let's say your actual pressure versus what your pressure should be with the head weight is too low. Well, then you don't have a full loop. And you need to get more water into that loop to continue filling it up the rest of the way. And now that's why you're having circulation issues. You don't have enough water in your loop to circulate all the water. Okay. Do you think about ultrasonic detectors? What do you think about ultrasonic detectors for checking the bearing and screw compressors and big machinery? Factory use it for some. Yeah, I think ultrasonics are great in so many ways. They're just so versatile, not only from bearings, because we used a stethoscope for a long time, the little heart, put it on your chest. It's like a great method. Doing the screwdriver, great method. So I think ultrasonic is great. Does it replace a vibration analysis? No, but it's not. You're not trying to, right? You're just trying to pick up the inconsistencies in the bearings. So that's what you're listening for. Is as those bearings are rotating, like a bad bearing will start to get loose, and it's going to have this pitch to it, or this frequency, and you'll hear this kind of rhythm as it's going, and it's not a smooth rhythm. And that's what that ultrasonic's helping you pick up and determine, and you can hone in on that without having to go through all the extra steps and process of vibe analysis and everything else. That's if you even have that tool available. So yeah, I think they're great. I'm absolutely a fan of them. Similar conversation to thermal imaging. I think thermal imaging is absolutely phenomenal, and I highly encourage everybody to try to use that. Yeah, really, really good. Would poor water flow through a YCIV cause discharge superheat? Cause low discharge superheat? Possibly. What should the differential across the barrel of a YCIV be? I think we have flow charts. Here, let's pull this question up. I'll take this will be the last question, and then we'll move on. Or I'll have to move on. Let's see. All right. Would poor water flow through a YCIV cause discharge superheat? What should the differential across the barrel of a YCIV be? All right. Poor water flow. So we're going to assume you're meaning low water flow. Can that cause low discharge superheat? Yes. That's going to be because, one, the compressor is not going to be able to stage up properly. So because the compressor, these are variable speed only compressors, they don't have any kind of a slide or volume indexing control in them. So the YCIV will, because it is slowing down, it will lower the discharge superheat you're going to see on the compressor. That being said, you should also have, suction superheat control via the drain valve on this machine. So I would expect to see suction superheat control and just the machine is slowing down in general. Now I can pull up the manual for the YCIV, and I'm pretty sure it has flowcharts in it. Because in terms of what should our differential be, well, that's going to come back to that machine's design GPM and such. So let me get this to open here for a second. And then I'll see if I can find the flowchart. And I just want to show you. Now, your access to this manual is maybe a different story. But if I have it here, I just want to show it to you. Which at that point, it will depend on, or it should depend on, what size of machine you have. So you didn't indicate what your, so for tonnage, you've got YCIV, right? So the next, 3 digits after that, there should be numbers. So those next 3 digits are your tonnage that we're working with, and that'll be part of what we need as a cross-reference. Oh, come on. Okay. iPad ain't working, so we're going to switch over to the phone. Just give me 1 second. I do want to find this before we all check out, and I send you on your way. Okay, let's come over here to 4. Let's see. Product. Rigging, installation. Where's our flow? Inputs, outputs. Commissioning. General, fans, grounding, water system, flow switch, temperature. Water pressure drop charts right there. So we're on page 59. Come on. All right, yeah, so this is the, which manual is this? This is the, yeah, so this is 201. Let me write this book down. You can search this, and this will give you your pressure drop chart. So you want 201.23 dash NM1. That has your pressure drop chart. Oop, come on. And then you can see, let's zoom this in. So there's your number. You can see right here we have our size. So depending on what size you have, this is how they all kind of fit in. That's your 60 hertz. Oop, let's go down to, no, I said 60. That's 50, 50, 50. I may have clicked into the wrong manual. Either way, you can get your hertz, the right hertz. I'd have to, well, I'm not going to take the time to go find it. So we have our pressure drop in feet of head, right? So it's H2O, feet, H2O. So we just convert that into a PSID. And then we have our GPM A, B, C, D based off of your particular tonnage on your machine. And then, yeah, you just need to track along this line, right? So if we had if we were using line A, then 30 feet of head. That's DP across, so 30 feet of differential between inlet and outlet. Divide that by 2.31. That gives you your DP. Would give us 500 GPM through that heat exchanger. And so we need to be somewhere on this range here. And ideally, target somewhere towards more of the middle to upper side. I try to stay away from the lower side, and you don't want to obviously exceed the upper side. But this is the chart you would want to use, right? So that's you can get that in the IOM itself, right there. That's what you're looking for. Okay. Hope everybody has a great week. I should see y'all next week, barring life and things going haywire as they sometimes do, and hopefully the grass fires stay down. We don't get too bad, but we'll see. They haven't sent out a countywide report, so that's a good sign. No task force. With that, take care. MTT, make the time for your family, for your spouse, for your kids. They really need you. It's really, really important. I'd love for you to come join all of us over at chilleracademy.com if you haven't already. We got some really great resources over there.